Assalamualaikum student. Today's topic is structure of sigma and pi bond. So let's start with the structure. So for example, here we got a p orbital which is having a dumbbell shape, and this one is the structure I'm drawing here is a sigma bond. Okay, sigma bond. Let's draw the structure of sigma bond. Okay, so here's for example is a double dumbbell orbital of any, it can be any substance. Okay, but this overlapping is called between the x-axis. This overlapping has been called sigma bond because it's been in the x-axis. Okay, so here we are taking the example of pi bond. So here we are having atom like this. Okay, so what will they do? Because they cannot change their position, like they cannot come here, so cause of that they will be doing overlapping like this. Means they will be side to side, or they will be making side to side overlapping overlapping and here the overlapping will be held through head to head overlapping. Okay, so cause of that, firstly let's look at the example of nitrogen. Okay, leave nitrogen, here we are having oxygen. Okay, so first of all let's what is the electronic configuration of oxygen? Oxygen's electronic configuration is 1s2, 2s2, 2p, 2 to 4, and oxygen contains 6 electron, so that's why 5 6. Okay, and here we are having 1s2. Oxygen contains I think 8 electron. Okay, so that's why 4 will be here. Okay, that's my mistake. Okay, 1s2, 2s2, 2p4. Okay, so this is the electronic configuration. And if you guys know about the p orbital, so p orbital is divided into px comma py and comma pz. Okay, pz number 2. Okay, these orbitals are divided into px, py, pz according to the axis. So if you know the Hund's rule, which states that we have to fill electron by one. Okay, so 1 2 3, and this one is 4. Okay, so this one is stable, but these both are not stable. Okay, so what they will do, they will means, now let's draw the structure of this one p here, 2px, 2py, and 2pz. Okay, so what these 2py and 2pz, what will be they doing? So for example this one is 2py. Okay, and this one, they will be making bond like this, they will be overlapping like this, like this. So this one overlapping will be held between them, and the electron will be oppositely spin, and cause of that means bonding, this one bonding is called sigma bond. And the first bond which forms between two orbitals is always a sigma bond. Okay, and now the last one is 2pz. So the 2pz will form like this, like here we were having 2py. So for example here we are having 2pz, so they will form like this, side to side sharing and side to side overlapping. Okay, so this is the structure. And pi bond always exists between the molecule. For example this one is the molecule of oxygen, O2, and this one is the pi bond. Okay, this one is the pi bond, and this one is the another pi bond. So that means pi bond exists between the molecule and the sigma bond. This one is the sigma bond. Sigma bond, uh, pi bond exists above and below the molecule. Okay, and sigma bond held between the molecule of oxygen. So that is sigma and that is pi. Okay, so this is a simple structure of sigma and pi bond. Okay, so hope you guys enjoyed our video. We'll see you in the very next video.